Your test tomorrow covers section 4.3 and 4.4. Your review does a good job to indicate what's actually on your test. So the first section that it goes over is using the change of base formula to simplify each expression and round all of your answers to 3 decimal places. So this one, remember your change of base formula is the log of your big number, so the number that looks like a whole number, over the log of your base. So for number 1, you have log 4 of 87. So you're going to take the log of 87 divided by the log of 4. So when you plug this into your calculator, if you round to 3 decimal places, you're going to have 3.221. For number 2, you are finding the log 15 of 31. So that means you're going to take the log of 31 divided by the log of 15. So again, plug this into your calculator. Round to 3 decimal places, you should get 1.268. Your next questions ask you to expand each of the log expressions. So for number 3, it gives you log 5 of 4x cubed times the square root of y all over z to the 6th power. We're going to rewrite your division using subtraction first. So that's going to give you log 5 of 4x cubed times the square root of y minus log 5 of z to the 6th power. We do not keep the radical on whatever term that's attached to, so we're going to represent it using a fractional power. So this is going to give you the square root, so that means that it's 1/2 as your power. So that's log 5 of 4x cubed y to the power of 1/2 minus log 5 of z to the 6th power. We do have multiplication here, which we can rewrite using addition. So you'll have addition between the 4 and the x to the 3rd, as well as between the x to the 3rd and the y to the 1/2 power. So that's going to give you log 5 of 4 plus log 5 of x cubed plus log 5 of y to the power of 1/2 minus log 5 of z to the 6th. Now you could also put parentheses around that whole front part before the subtraction, so that way it designates that it's up top on your fraction. From here, you do have to move your powers to the front of each of those expressions. So that power of 3 is going to go to the front of that log 5. The power of 1/2 is going to go to the front of that log 5. And that 6 is going to go to the power, or sorry, to the front of that log 5. So that's going to give you log 5 of 4 plus 3 times log 5 of x plus 1/2 times log 5 of y minus 6 times log 5 of z. For number 4, you have log 2 of 3x to the 4th power, y to the 9th power, z. So you have multiplication happening here between the 3 and the x to the 1st, so we'll represent that with addition. You also have multiplication between the x to the 4th and the y to the 9th, so we use addition there, as well as between the y to the 9th and the z, so we'll use addition there. So it's going to separate to give you log 2 of 3 plus log 2 of x to the 4th plus log 2 of y to the 9th plus log 2 of z. From here, you have powers, so you're going to bring those powers to the front of each of those expressions. So your 4 moves and your 9 moves. So it's going to give you log 2 of 3 plus log 2, plus 4 times log 2 of x plus 9 times log 2 of y plus log 2 of z. For number 5, you have log 6 of the cube root of xy all over 3z squared. You can rewrite this representing that cube root with the power of 1/3. And you can also represent the division with subtraction. So we're going to do the power first on that radical. So that's going to give you log 6 of xy to the power of 1/3. You realize that parentheses go around the xy because it's all underneath that radical. From here, we represent the fraction with subtraction, representing this with division, right? So, or with subtraction, so that this would become log 6 of xy to the power of 1/3 minus log 6 of 3z squared. All right, so now bring that 1/3 to the front. So that's going to give you 1/3 times log 6 of x times y. Then you're also going to separate the 3 and the z squared with addition. So that's going to give you log 6 of 3 plus log 6 of z squared. So from here, you're going to separate the x and the y with addition since it's multiplied. You're also going to bring that 2 to the front on that log 6 of z squared. So it's going to give you 1/3 times log 6 of x plus log 6 of y minus log 6 of 3 plus 2 times log 6 of z. We look at our next section. It tells us to condense each expression to be one single logarithmic expression. For number 6, you have 4 times log 3 of x plus 1/3 times log 3 of y minus 2 times log 3 of z. This 4 is your power on your x, the 1/3 is your power on your y, and the 2 is your power on your z. So we're going to rewrite these to be log 3 of x to the 4th power plus log 3 of y to the power of 1/3 minus log 3 of z squared. We're going to simplify that power of 1/3 first before we do anything else. It is representing the cube root, so we're going to just rewrite this to be log 3 of x to the 4th power plus log 3 of the cube root of y minus log 3 of z squared. Addition gets rewritten using multiplication. Subtraction gets rewritten using division. So this is going to give you log 3 of x to the 4th power times the cube root of y all over z squared. For number 7, you have log 4 of 7 plus 1/2 log 4 of x plus 1/2 log 4 of y minus log 4 of 3 plus 9 times log 4 of z. So for these, you have the numbers that are in front of that 1/2. So it becomes the power on x. The 1/2 becomes the power on y. Your 9 becomes the power on z. So it's going to give us log 4 of 7 plus log 4 of x to the power of 1/2 plus log 4 of y to the power of 1/2 minus log 4 of 3 plus log 4 of z to the 9th power. Rewrite those fractional powers as radicals. So you're going to have log 4 of 7 plus log 4 of the square root of x plus log 4 of the square root of y minus log 4 of 3 plus log 4 of z to the 9th. From here, rewrite your addition with multiplication. You can also rewrite your subtraction using division. So that's going to give you log 4 of 7 times the square root of x times the square root of y all over 3 times z to the 9th. If we bring this all together, because you have those two square roots, you're going to multiply the x and the y, keep it underneath the single square root, and this is going to give you log 4 of 7 square root xy all over 3z to the 9th. For number 8, you have 3 times log 2 of x minus 5 times log 2 of y plus 8 times log 2 of z. Your 3 becomes your power on x, your 5 becomes your power on y, 8 becomes your power on z. So it's going to give you log 2 of x cubed minus log 2 of y to the 5th plus log 2 of z to the 8th power. Rewrite your addition using multiplication. Rewrite your subtraction using division. You're going to have log 2 of x cubed over y to the 5th, z to the 8th. Your next part, you're just solving. So remember with these, you want to try to, if your x is in your power, you want to bring your power down. If you're working with e, you want to cancel it out by using the natural log, so ln. And then if you're working with log, cancel it out by using your base. For number 9, you have 4 to the power of x is equal to 64. You can rewrite that 64 as 4 to the power of something. It is 4 cubed, so that means that you would have 4 to the power of x is equal to 4 to the 3rd power. Your base is the same on both sides now, so you can cancel them out, and you just have that x is equal to 3. For number 10, you have e to the power of 3x is equal to 1.27. To get rid of e, we use ln. So we're going to take the natural log of both sides, and this is going to give us the natural log of e to the power of 3x is equal to the natural log of 1.27. ln cancels out e, so you have 3x is equal to ln of 1.27. Before you use your calculator, you are going to move your 3 over. So divide it by 3 on both sides, and this will give you x is equal to the natural log of 1.27 divided by 3. So in your calculator, when you use it, you have to find the natural log of 1.27 first, and then divide that answer by 3. If you round to 3 decimal places, you should get 0.0796. That 9, you're looking at the number to the right of it to move it up or keep it. 6 is greater than 5, so that 9 is going to go move up. If the only way to move the 9 up is to make the 79 and 80. So this is going to give you that x is equal to 0.080. For 11, you have the natural log of x is equal to negative 2.4. You are using e in order to get rid of that natural log. So that's going to give you e to the power of ln of x is equal to e to the power of negative 2.4. E cancels out ln, so you have x is equal to e to the power of negative 2.4. If you use your calculator and you round to 3 decimal places, you should get that x is equal to 0.091. For 12, you have log 4 of 3x is equal to log 4 of x minus 6. You have this log 4 on both sides. So because it's on both sides, they can cancel each other out. And you just have 3x is equal to x minus 16. Move your x over to be with the 3x. So subtract it from both sides. It gives you 2x is equal to negative 16. Divide each side by the 2. And you have that x is equal to negative 8. Now, you cannot take the log or the natural log of a negative number. If you were to plug this in, you would have 3 times negative 8. So that's log 4 of negative 24. You can't do that. So this is an extraneous solution. Tomorrow, it will ask you to identify any extraneous solutions. So that is just what you'll do with your answer. So whatever your answer is, you'll just put ES, meaning extraneous solution, next to it. For number 13, you have the natural log of x plus the natural log of 4 is equal to 6. Same rules apply with natural logs that they do with logs. You have addition here, so you'll represent that with multiplication. So that's going to be the natural log of 4 times x is equal to 6. Again, e cancels out ln, So you're going to take e to the power of ln of 4x is equal to e to the 6th power. E cancels out ln, so that's just 4x is equal to e to the 6th power. Again, don't use your calculator yet. Move your 4 over, get x by itself, divide it on each side, and then use your calculator. So in your calculator, you're going to type in that second ln button to where you get that e to the power of 6, hit enter, and then divide it by 4. And that should give you 100.857. For 14, you have log 2 of 3x to the power of 7 is equal to 49. That 7, since it is your power, is going to go to the front. And that's going to give you 7 times log 2 of 3x is equal to 49. Divide each side by the 7 to move it over. And you have log 2 of 3x is equal to 7. Your base on that log is 2. So in order to cancel out that log, you're going to use 2. So that's going to give you 2 to the power of log 2 of 3x is equal to 2 to the 7th power. Simplify on the left side by canceling out the 2 and the log 2. That'll just leave you with 3x is equal to 2 to the 7th power, which is 128. Divide each side by the 3. You do not need to simplify this any further. You can leave it in fraction form to be the 128 over 3. And then this is perfectly fine because it's not a negative, so that would be your answer. For 15, you have log 2 of x plus 3 is equal to 4. So for this one, you can't move anything over yet. You have to get rid of that log. Your base on that log is 2, so we're going to have it be the base on both sides. So it's going to give you 2 to the power of log 2 of x plus 3 is equal to 2 to the 4th power. Your 2 cancels out your log 2 on your left side, so you're left with x plus 3. And then that 2 to the 4th power is 16. Move your 3 over by subtracting it from both sides, and you get that x is equal to 13. For your last question, you have 2 times log 5 of x minus log 5 of 17 is equal to 0. You're first going to move that 2 to be the power on x, so that's going to give you log 5 of x squared minus log 5 of 17 is equal to 0. From here, you are going to rewrite your subtraction using division. So you have log 5 of x squared over 17 is equal to 0, not 10, 0. Your base on that log is 5, so you're going to have that be the base on both sides. You're going to have 5 to the power of log 5 of x squared over 17 is equal to 5 to the power of 0. Your 5 cancels out your log 5, so where you just have x squared over 17 on your left side is equal to 5 to the power of 0. Anything to the power of 0 is 1. Move your 17 over, multiply it from each side or by each side. It's going to give you x squared is equal to 17. From here, you're going to take the square root of both sides. That's going to give you that x is equal to the negative square root of 17 and x is equal to the positive square root of 17. We said before that these negative answers, when you're dealing with log or ln, are extraneous solutions. So the one that is the negative square root 17 is an extraneous solution.